Hello, champions. Welcome back to Math Bison. In today's video, we are continuing on our quantitative reasoning questions. As you rightly know, we're going to be sharing quite a lot of insights on how to get ahead in your quant. Let's continue shortly. Today, we are starting with this pattern where you have your samples. All right. So we're going to go through the same process, a thought process that we have been using to solve our quant questions. So we take the first sample and let's see what is going on there. So we have this rectangular box, the big one, and we have the smaller one, the mini one in the center. Although we don't have any figure right in the middle of this one, but let's see what is happening between the numbers. So if you look at our first step, which is trying basic operations, we see that 2 plus 3 gives us 5, and half plus 3 over 2 is not half. 7 plus 1 is not 3. So we know that this addition is not working. So what if we do 2 plus 1? We have 3. We have half plus this. That's like 3 over 4. Not 3 over 2. 7 plus 4 is not 1. So that's not working also. Somehow, if we say 5 minus 2, we have 3 here. But half minus half in the second sample does not give us 3 over 2. And 3 minus 7 does not give us 1. Notice how I'm always going in the same direction when I'm checking. So I said 5 minus 2 here is equal to 3. 5 minus 2 equals 3. But half 5 minus 2 is not equal to 5. Half minus half is not equal to 3 over 2. And here, 3 minus 7 is not equal to 1. So this is what I'm saying. In the same direction, guys. In the same direction. 2, you can't say 5 minus 2 and you come here and say half minus half. You now come here and say 7 minus 3. So you see there's a difference. You're going right to left here. Right to left, and you got here, you're trying left to right. It's probably because you notice that 3 is less than 7. It doesn't matter. You always have to stick to the direction of operation. All right, so let's continue. Let's try something that works. I've checked basic operations. Basic operation, addition and subtraction. I'm not saying it yet. Maybe it's still there. Maybe there's need for a combo. Yes. So let's try a combo. Let's see how it goes. So the combo is going to be like a combo of operations, of basic operations, say addition and combined with what? With multiplication. And let's see if we can establish a relationship. Now, if you say 1 plus 5, is it to say that 2 times 3 equals 6 and 1 plus 5 equals 6 also? So half, let's try with the second sample. Half times 3 over 2 should give us 3 over 4. And on the next one, we are going to do doing addition. 1 over 4 plus 1 over 2 should give us 1 plus 2, which is 3 over 4. So they're the same here. They're the same here. And let's check the third one if we get lucky with this. 7 times 1 equals 7, and 4 plus 3 equals 7. So that's also correct. We found something that works. So are we stopping here? No. We're going to look at, okay, what if any part of this diagram is missing? How do we attend to it? How do we figure it out? So let's go. Now, assuming that this 2 is the one that is missing, what do we do? The first thing we need to do is that we see there's a symmetry kind of answer between this operation and this operation. So the right thing you want to do is to start with this part, 1 plus 5, and you get a 6. And the next thing you are going to think is, okay, reverse engineering. It means that whatever is here multiplied by 3 should also give me 6. So I can create a kind of open sentence. Times 3 should give me 6. And by reverse engineering, if you do times 3 to get 6, you should be doing divided by 6 to get that number. So this number is going to be what? 6 divided by 3. And we're going to have 2. The same thing works for 3. If 3 is missing, let's say we have 2 times a number, gives us 6, then we should know that that number will be 6 divided by 3 or by 2 will give us 3. What if any of the numbers in the second, the addition part is missing? We're going to first of all focus on how to get this number first by using the first operation, which is 2 times 3. 2 times 3 gives us 6. So whatever we add here must also give us 6. So we have 1 plus 5. Sorry, in case 1 is missing, in the case where 1 is missing, I'm going to have a question mark there, not 1. But I know that if I add 5 to it, I should have a 6. So that number that's missing is when you do reverse engineering of this or reverse operation, you're going to have 6 minus 5. 6 minus 5, and you have what? You have 1. So that number that is missing is number 1. If you have 5 missing, then I have 1 plus a missing number equals what? 6. Then I should know that this missing number is 6 minus 1, which is 5 in this case. So having explained this like this, I think we are good to move on to some exercises. Okay, let's see. If we have this, $29, in this case, there's a missing number in this part, and we have 13, and we have 23. So how can we use this method of thinking to get our answer? We already know that we are doing 2 lines of operations. We do multiplication, and we also do addition, and our answers must be same. Remember the positions and remember the directions. Since multiplication and addition are commutative, perhaps can we also say that direction does not matter in this case? Yes, because 1 times 5 is 5, 5 times 1 is 5, so direction does not matter. Now let's go. So here we have, we are using in part A, B, C, D. From the sample that we have solved, we know that we are always going to multiply the part D and C. In this case, it is the question mark, which is number missing, and 13. And we are going to always add the part A and B. And in this case, it's going to be what? 29 plus 23. So to continue, we need to continue with what? Where we have all of the numbers provided. In this case, 29 plus 23. This is going to be what? 50, 52. So if 29 plus 23 gives us 52, now we have a case where a particular number multiplied by 13 must also give us 52. So what do we do? By reverse engineering, guys. By reverse operation. So what do we do? If we multiply a number by 13 to get 52, we should be looking at, to get that number, we should be looking at 52 divided by 13. And that number should be 4. Because, yes, 40. 13 times 4 should give us 52. So that is it. That's the answer, guys. That's the answer. The answer is 4. So you see that this system of thinking with your quant is going to be very helpful. Now let's try the next exercise. Exercise question 1. The next one is and we have 2, 13, question mark, and 8. So we know that we have part A, B, C, and D. And from the rules that we have set, D must always multiply C to get a particular number. And A must be added to B to get the same answer. In this case, D times C will be 2 times 8. And A plus B will be 13 plus that missing number. But if we write, we see that 2 times 8 gives us 16. It means that 13 plus this number must also give us 16. So by that, by reverse engineering, if we have 13 plus a number to get 16, that number will come out to say hello the moment we do 16 and subtract 13. This is going to be 3. So 13 plus 3 gives us 16. So that number that is missing here is 3. Now let's check with the next question. Question 3 is 2, 3, 7, and a question mark. Guys, remember the rules we have set. This rule we set is that this part A and part B will always be added, part C and part D will be multiplied. So what does this mean to us? A plus B must be same as D times C. And in this case, A plus B is 2 plus 7. And D times C will be 3 times this question mark. Guys, if you write this 2 plus 7, you should have 9. It means that 3 times this missing number should also give us 9. And it's obvious because the numbers are so light, like feathers, we can easily see that that number is going to be 9 divided by 3. By reverse engineering, 9 divided by 3 should give us this. So we have 3. This missing number, guys, is 3. Now let's check with the last question. For this sample, okay, let me do a clean one. And we have this, we have this, we have this, we have this, here and here. Okay, in this one we have 3. There's a question mark up here. We have 1 and we have 6. So I'm labeling again as part A, B, C, D, such that A plus B we give the same answer as D times C. A plus B in this case is a missing number plus 1. And D times C in this case is 3 times 6. And what are we going to do, guys? Here, we are obviously seeing that that missing number plus 1 should give us what? The same answer as 3 times 6, which is 18. Now, if a missing number plus 1 is going to give us 18, plus 1 gives 18, then that missing number must be 18 minus 1. So we have 17. That's the answer, guys. All right, let's take another sample and look at how this system of thinking can help us fix our quant easily. Now, we're having a new sample, and that sample is, okay, let's not overthink it. Let's go back to the system of thinking. Let's start with basic operations. Basic operations. Basic operations. In the basic operations, we should have what? Math, addition, subtraction, multiplication, you multiply, and you divide too. Okay, so let's try. 2 plus 3 gives 5. 3 over 2 plus 1 over 2 should give you 2, which is 4 over 2 should give you 2. But 7 plus 3 does not give us 17, so something is not right there. 2 plus 3, 1 times 5. But 2 plus 3 did not even work, so we can't use it. 1 times 5, 1 times something to give us 5. No, it's not working too. Division. Division is also not working. 7 divided by what? Nothing is looking divisible here. But guys, the first thing that strikes on a second look is that you have perfect squares up here. Maybe there's something they're telling us. We have perfect squares up here, and those numbers are telling us some very interesting stories. So what are those stories? Why not we try the square root of these numbers and see if we can work with them? Okay. 2 times 3 is 6. And the square root of 1 is still 1 plus the square root of 1 is still 1 plus 5 gives us 6. Looks like something. Let's see if that works here. 3 over 2 times 1 over 2 should give us 3 over 4. The square root of 1 over 4 plus 1 over 4 should give us what? 1 over 2 plus 1 over 4. This is going to be 4 here, 2 here is 2 times 2. 2 plus 4 in 4 is 1 times 1. And you have 3 over 4. They are the same. We got 6 and 6. We got 3 over 4, 3 over 4. Let's check with the third one before we take this in completely. So we have 7 times 3 and it's 21. And the square root of 16 plus 17 will give us what? 4 plus 17, which is 21. Perfect. I think we're good. So now, the next question should be, how do we get other parts when any part of this is missing? Just similar to what we did in the other question, in the previous question, what we're just going to be doing is to ensure that our answers are always same. And once you get which answer you're looking for, which result you're looking for in each operation, it will be easy to figure out. But this time around, there's a square root. Remember, in our other video, we mentioned that the reverse for square root is what? Is the square. So we're going to make use of our square and square root together in this one. So let's check. If 2 is missing from here, if 2 is missing, and I have to have a 3 and a 6, we know that we're simply going to do 6 times divided by 3, and it will give us 2. If 3 is missing, I'm going to do the same. 2 times a missing 3 will give us 6. Then this missing number is 6 divided by 2, and I also get 3. Now, in the second operation, if the square root, if this figure 1 is missing, I know that that number here is the square of a number, square of a missing number, plus 5 must give me what? 6. So the first thing I want to do is reverse engineering, guys. The square of a missing number is going to be what? 6 minus 5, which is 1. What number will give me a square root that is what? Equal to 1. It is still 1. So that number is 1, guys. Now, it's going to be the square root of this will give me, the square root of this missing number will give me 1. So how do I get that number? I need to do the square of this particular side. To get only that number, I have to do 1 squared, which is what? 1. All right, let's try with 5 missing. If 5 is missing, and I know that the square root of 1 plus a missing number will give me 6. I already know the square root of 1 to be 1 plus this missing number should give me 6. This missing number should be 6 minus 1, and I should have 5. All right, it is time to take some exercises on this. Okay. So let's have the first one. 1 over 9. A question mark here. 8 over 9. And we're dropping 1 over 9 again. In this one, if we follow the instruction, we know that this part A, so let's just multiply part B here, C and D. C and D will add, and we have to have the same answer. Our question mark, which is the missing number, multiplied by 8 over 9, must give us the square root of 1 over 9 plus 1 over 9. Yes, because here is a perfect square. So what we're doing now is for us to simplify this side. Then we have square root. So we have this missing number over 8 over 9 equals what? Square root of 9 or 1 over 9 is 1 over 3. Now plus 1 over 9. We should have 9, 3 plus 1, which is 4 over 9. This missing number times 8 over 9 should give us 4 over 9. And by reverse engineering, that missing number will be what? 4 over 9 divided by 8 over 9, which is 4 over 9 times, remember, in division, multiplication and fraction division, we're going to somersault the numerator and denominator so that they swap positions. We have 9 over 8. 9 takes 9, 4 here 1, 4 here 2. We have 1 over 2, guys. So the number missing is 1 over 2. One over 2. All right, the second question says this. There's a missing number here. 3 times 6 must give me the square root of that number plus 15. 3 times 6 is 18. And I'm having a square root plus 15. I should know that the square root of that missing number must give me what? 18 minus 15. Yes, and that should be 3. There's a number, if I look for the square root, I'll have a 3. What is that number? By reverse engineering, guys, don't stop here and say the answer is 3. You need to have that number itself is not equal to 3. That number itself is equal to the square of 3, which is 9. Because that's the only way the square root of 9 will give you 3. Yes, this is what this is saying. But the number itself is the square of this 3. Remember, we mentioned that we're going to be using our square and square roots together to find the reverse operations. All right, the third one, the third one now, we have this, and we have 4, we have 1 question mark, we have 7. We already know that 1 times this question mark, that missing number, should give us the same thing as the square root of 4 plus 7. From the right side, we can see that everything is looking okay. 2 plus 7 should give us 9. So 1 times a particular number should give us 9. Then 9 divided by 1 should give us that number, which is still 9. The last one on this sample is going to be this 25 and this. We have 4, we have 9, and here you have a question mark. Guys, it's the same thing. 9 times 4 should give us the same answer as what? The square root of 25 plus this missing number. 9 times 4 is 36, and the square root of 25 is 5 plus the missing number. So by reverse engineering, 36 minus the missing number should give us that missing number, guys, is 31. All right, let's take the last sample in this video. So let's see what's happening using the same system that we've been using. We try basic operations first. If a basic operation is not working, try combo. Do a combo of basic operations. If it's not working, bring your square of numbers and square roots. If it's not working, you bring your cubes. Now, sometimes you have magic numbers, something is multiplying, a hidden number that's multiplying another. But let's see if that is the case here. So basic operations first. Add, subtract, multiply, and divide. Let's go. 2 plus 1 does not give us 5. 2 times 1 does not give us 5. 3, 3 times 2 does not give us 11. 3 plus 2 does not give us 11. So addition subtraction doesn't seem to work. Perhaps we need to do a combo. What if we have 2 and we have divided by 1, you have 2. 3 divided by 2, that's 1.5. Nothing is working here. Let's try squares. Here, square of this is 4. And I can see automatically that 4 plus 1 gives me 5. The square of this, 3, will give us 9. 9 plus 2 gives us 11. The square of this gives us 1 over 4. And 1 over 4 plus 3 over 4 should give us 1. Okay, let's try. 2 squared plus 1 should give us 5. 3 squared plus 2 should give us 11. 1 over 2 squared plus 3 over 4 should give us 1. And it is true because here is 4 plus 1. And you have 5. Here is 3 squared, which is 9 plus 2. And you have 11. In this case, we have 1 over 4 plus 3 over 4. And you have 4 over 4, which is equal to 1. This is it, guys. But how do we get other missing parts? If 1 is missing here, we square this number. We are looking for a number to be added to it to get 5. Then we just do this number should be what? 5 minus 4, which is 1. If 4 is okay, that's about it. Let's take 2 more exercises. Okay, we have the first one. Question mark. We have 5. We have 9. How do we do this? We know that here is a square. We're going to square that number and we will add it to 5 and the answer should be 9. So that number, which I will square, is going to be 9 minus 5, and this is going to be what? Remember, I'm repeating the square. It's going to be what? 4. If a number is squared to get 4, we use reverse engineering. The reverse operation will be what? Square root. So we're going to have the number itself will be what? The square root of 4, which is 2. We want to check that 2 squared plus 5 will give us what? 9, because 4 plus 5 gives 9. Let's check the last question. The last question here is same diagram. So in this case, we know that the first part A is going to be squared. Then we add it to this missing number and we should have 13. The missing number should be the same number you have if you subtract the square of 3, which is 13 minus 9. And 13 minus 9 is 4. So this number so missing is going to be 4. You can check to see that 3 squared plus 4 should give us 13. 9 plus 4 is 13. Thank you very much. It is the end of the second part of our quant video. Thank you for listening. See you again in another video.